Hello students, today we are discussing about magnetic field around a straight current carrying conductor. Current carrying conductor, it's a finite current carrying conductor. A finite current carrying conductor, finite length. So in generally, if you see, there is a straight current carrying conductor. Okay. So it's what? Just let it be the current is what? Downwards. Yes. So Ampere's right hand thumb rule. Okay. So the field, for example, if I want to find this at this position, what is the field? Means what it is the out the plane. Yes. Now the perpendicular distance where you want to find the field is the perpendicular distance. This perpendicular distance I am taking as A. Okay. So now the line joining from here, this and next one is this one. So it makes an angle theta 1 and next one is what? Angle theta 2. So downward angle is taken negative, and from this perpendicular length, okay, so downward is taken negative and upward is taken as positive. Okay. So now this can be written as, so finite length is taken, it's a finite length, and next one where you want to find, I want to find at this position, it's into the plane, the current is downwards. Okay. So I am choosing, this is the angle, okay, which makes an angle, it's what? Like this. Okay. First one is theta 1, next one is what? Theta 2. So from this I am choosing a small length element. This is the length element. Length element or current length also. So length of this one, this is what? IDL. I am writing this is a direction. It's a small length element is taken. Its direction is what? Downward, IDL. The length from here to here is taken as, it's a L. Okay, like so. Small length element is considered. This length element DL like so up to from this end to this end, the total length will become as L. Okay. So now we are choosing, this is what the angle made by this at this by the length element. This part is what I am taking as, it's a theta. Theta, it changes from the minus theta 2 to plus theta 2. Theta, it changes from minus theta to 2. So, okay. So, that's what theta 1 is the condition. So, now I am talking about from whenever the infinite length, okay. So, otherwise it is a finite length, any current carrying conductor. So, we have a best principle to calculate the magnetic field, that is what? Biot-Savart law. Okay. So, I am using the Biot-Savart law. Okay. So, from Biot-Savart law. Okay. So, Biot-Savart law. So, what is the Biot-Savart law? Is B is equals to, it's a dB is equals to mu naught by 4 pi. dB is equals to mu naught by 4 pi I dl sin theta by r square is the general form. So now first of all we should know this is what I want to know, this dl, and next one is the r from this picture. Okay. So from this triangle is what? Tan theta I am taking this, it's a tan theta. Tan theta is equals to L by, this length is perpendicular length is taken as L, and this is what? It's a R. Tan theta is equals to L by, it's a, then L is equals to, you can write A tan theta. Okay. So then DL is equals to, we can write A secant square theta d theta. Okay. It's a DL. First one I know, I got it, the information about it, it's a DL. Now I want to know about what is the R. R is what? From this is what? From the same triangle. Okay. Cos theta is equals to, adjacent is A by R. Then we can write on this, R is equals to A by cos theta. R is equals to A by cos theta. So this is what? R is equals to A secant theta is next more information I got from this. So from this is what? Now directly I can substitute on this. So here we can say dB is equals to mu naught by 4 pi, mu naught by 4 pi I, and it's a dl is what? So this dl is what you written, a into secant square theta d theta and sin theta, theta. What is the theta? Sin theta means what? With length element, what is this angle is what? It's a this. Okay, this is theta, this is 90. It's a 90 minus theta. Otherwise, alpha you can write it as alpha is equals to 90 minus theta. Also, we can write this. So it's a sin 90 minus theta by, okay. So r square means what? A secant theta whole square. Okay, so carefully now, this dB is equals to, now I am continuing this, it's a dB is equals to, okay, so mu naught by 4 pi, it's a mu naught by 4 pi I. Next one, here a square, this is what, one a is cancelled, secant square theta is cancelled. Okay, mu naught I, one a, so a is the denominator, and next one is, so cos theta, okay, it's a cos theta, sin 90 minus theta is the cos theta, and denominator is what? A. So B is equals to mu naught I by 4 pi A times of integration over cos theta, it's a d theta left, correct? Here, so d theta, this is a d theta left. So now limits from where? Minus negative angle is what? Minus theta 2 to theta 1. B is equals to mu naught, okay. So it's a mu naught I by 4 pi A times of cos theta is what? It's a sin theta. Limits are taken from minus theta 2 to theta 1. B is equals to, so mu naught I by 4 pi A times of sin theta 1 plus sin theta 2 is the required relation. Okay, so this is the magnetic field due to current carrying conductor or around the current carrying conductor. So what is that? Finite length. So B is equals to mu naught I by 4 pi A sin theta 1 plus sin theta 2.